This is lesson 8-6, factoring ax squared plus bx plus c. To factor quadratics that have a coefficient in front of the x squared other than 1, we use a procedure called the AC method. It's very similar at the beginning to what we did last lesson with the basic trinomial method. The first step is to multiply a and c to get AC. In this case, a is 8, c is -1, so when we multiply them, we get -8. The next step is to find the factors of AC. From there, we want to choose a pair that will add up to the b term. Factors of -8 that will add up to +2 are +4 and -2. The next step is to separate the b term into two factors, and then we will have 4 terms. This process is also known as factoring by grouping. So I'm going to split up the b term into -2x, +4x. My personal method of preference is to put the smaller factor first and put the larger factor second. Next, we're going to split the terms in half. We're going to group the terms. So I may draw a little squiggly line like right down the middle here just to separate the sides. Next, I need to use the GCF factoring process to factor each side of my line that I just drew. When I factor, I should end up with a match in my parentheses, meaning that what's in the parentheses matches. On the left side, I can factor out a 2x. When I do that, I'm left with 4x minus 1 in parentheses. On the right side, the GCF is 1. So literally, I am going to write a 1, even though in the past with GCF factoring, we have not written a 1 outside of the parentheses. It is important to do it in this particular instance because we are going to take the two GCFs and make them their own set of parentheses. In other words, we're doing reverse double distribution. And that's what step 7 is. We're going to write our two binomials from the match and the factors that were pulled out. So my two binomials are going to be the quantity 2x plus 1 times the quantity 4x minus 1. Let's take a look at some examples. Pause the video at this point to give yourself a chance to do the examples on your own. Let's take a look at the left side. The first thing we have is 12 times -15, which gives me a -180. Factors of -180 that add up to 11 are +20 and -9. I then will separate my b term into those two factors. 12x squared minus 9x plus 20x minus 15. Then I'll split up the factors into two groups, right down the middle like so. Then I'll factor out the left side, which gives me a 3x, and factor out the right side with a 5. On the left, I'm left with 3x times the quantity 4x minus 3, and 5 times the quantity 4x minus 3. Since I have a matching set of parentheses, I can continue and write my two binomials as the quantity 3x plus 5 times the quantity 4x minus 3. On the right side, my AC is -14. Factors of -14 that add up to -13 are -14 and +1. I'll split my b term into those two factors, and I have 2x squared minus 14x plus x minus 7. Splitting the factors in half like such, and factoring the left side with 2x, factoring the right side with 1 gives me 2x times the quantity x minus 7 plus 1 times the quantity x minus 7. Rewriting in two binomials will get me to the quantity 2x plus 1 times the quantity x minus 7. Factoring completely is something that we need to do when we have a GCF as part of our trinomial. The first thing you want to do is look to see if a GCF exists. If it does, factor it out. In my example, 2 is a GCF of the entire trinomial. I'm going to factor it out, and I'm left with 12n squared plus n minus 6. Then I want to take a look at what's in the parentheses, and I want to continue to factor an appropriate procedure, either basic trinomial or the AC method. In this case, because I have an a value greater than 1, I want to use the AC method. So I will multiply 12 and negative 6 to get negative 72. Factors of negative 72 that add up to positive 1 are positive 9 and negative 8. I'll then split my b term so that I get 12n squared minus 8n plus 9n minus 6. Then, in the parentheses, I'll factor by grouping. Drawing my line down the middle, I will then factor the left side and pull out a 4n. Factoring the right side, I'm going to pull out a 3. When I do such, I'm left with n minus 2 in both sets of parentheses. This means I can continue and write my two binomials. I'm left with my final answer of 2 times the quantity 4n plus 3 times the quantity n minus 2. Here are some examples. Pause the video at this point to give yourself a chance to try them on your own. Let's take a look at the left side. The GCF of that entire trinomial is 15. When I factor it out, I'm left with 2a squared plus 5a plus 3. I need to use AC method because my a value is greater than 1. 2 times 3 is 6. The factors of 6 that add up to 5 are 3 and 2. So I'll split my b term in the middle to get 2a squared plus 2a plus 3a plus 3. I then will split my terms so I can factor by grouping. On the left side of my line, I'm going to pull out a 2a. On the right side, I'm going to pull out a 3. I'm left with a plus 1 in the parentheses that match. Now I can rewrite it in the form of two binomials. I'm left with 15 times the quantity 2a plus 3 times the quantity a plus 1. On the right side, I have a GCF of 2, so I'll factor it out and be left with a squared plus 7a plus 6. This I can use the basic trinomial method that we learned in lesson 8-5. Factors of 6 that add up to 7 are 6 and 1. So I can write two sets of parentheses with a in front and put in a plus 1 and a plus 6. I'm left with 2 times the quantity a plus 1 times the quantity a plus 6. If you're having any difficulty with this particular lesson, please consult your teacher in class.